In this video, we're going to look at a couple of different examples of working with our hyperbolas. And here we have our standard equations for the hyperbola, and also we have the formulas for the asymptotes. And if we're given the following equation, let's say that we have x squared divided by 9 minus y squared divided by 25 is equal to 1. And we want to identify the center, the vertices, the foci, and the asymptotes. So first of all, we're going to go up here and look and figure out, is this going to be horizontal or vertical? Well, we can see that we actually have the x squared is first. So here we have the x squared, so that tells us it's going to have a horizontal axis. So what that means is we know that it's going to open to the left and to the right. All right, next we want to be able to identify what is going to be the A, B, and C values. And we can look here, and we know that the 9 here, that's going to be A squared. So A squared is equal to 9. So that means A would be equal to 3. So therefore 25 is B squared. So therefore B is equal to the square root, which would be a positive 5. And then of course, if we're trying to find the C value, C squared is equal to, remember here, it's A squared plus B squared. So that would be the square root of A squared, which is 9, and the B squared is 25. So that's going to give us the square root of, whoops, and this would be C, not C squared. I've already got the square root here, so that gets rid of, so this makes it C equals the square root of 9 plus 25. So 9 plus 25 tells us C is equal to the square root of 34. So now at this point, we can actually go ahead and start to plot some of these points and figure out where the center, the vertices, and the foci are located. So if we start out, we're going to locate the center, and the center is going to be located where? Well, because we're looking up here, remember H and K is representing the center, so what are we subtracting from the X and what are we subtracting from the Y value? And this example, we'll notice we're not subtracting anything away, so therefore the center is simply at the origin. All right, then we want to identify the vertices. Well, just like when we worked with the ellipse, the vertices are a distance of A from the center. So here we have our A value is equal to 3. So that means we're going to have to go 3 places to the right and also 3 places to the left. So that's going to give us our vertices. And because we're moving strictly left and right, that means we're looking at the X value. So that means X could be a positive or negative 3, and the Y is going to remain 0 because it's on the X axis. So now what that tells us is we know that it's going to open something like this for the hyperbola. And then if we want to locate the foci, and again, we know that they're going to be somewhere on the inside here and on the other side. And the distance from the center to the foci is going to be the value of C. So here's our C value. We said was the square root of 34. Okay, so that means that's going to go here and here. So I'll just label this as the square root of 34, or negative square root of 34, and this would be positive square root of 34. So that means the coordinates would be either a positive or negative square root of 34, and the y coordinate once again would be 0 because we're on the x-axis. And then next we want to look at, if we found the foci, we could now find the asymptotes. And remember, this is where we're going to kind of form up here. Let's see, I don't have it in this particular video, but we're going to form that rectangle here, and the vertical asymptotes will cross through the corners of the rectangle. Now, if we recall, the rectangle is made up of the value of A and the value of B. So we know A is equal to 3, so we know we're going from the center out here to 3, and then for the B value, that's going to tell us how high up we go. So 1, 2, 3, 4, 5, and we would go 1, 2, 3, 4, 5, so it's a negative 5. So that means we're going to form our rectangle here, and our asymptotes then are going to cross through the corners, the center, and the other corner, okay? And what that shows, and this isn't quite drawn to scale here, but then that tells us then as we go through our uh, vertex here, kind of shows us how the graph is going to open up. So in this case, if I redraw this a little bit, it's going to open up a little bit wider here like this, because this is going to follow along and it's not going to touch the asymptote that goes through here. So we know where the asymptotes are located now because they're going to go through here the corners of this rectangle and also the center. And if we are looking at the formulas up here, because we have a horizontal axis, then that means we're going to use this first one where y equals k plus b over a times x minus h. And I'm going to simplify this because the only difference between this one here and over here is one's positive and one is negative. So we can actually write that together if we would like. So we could think of that as y equals k plus or minus b over a times x minus h. So all we have to do now is plug in for k, h, and b and a. So therefore we know our k value up here, the center is h and k, and that's the origin, so that's k is 0. Our b value is 5, a value is 3, and then x minus h, the h value is 0. And we have our two equations for the asymptotes. Now, of course, we can eliminate the 0, so we would actually just simply have positive or negative 5/3, and x minus 0 would simply be x. So here we have plus or minus 5/3 x as the two equations for the asymptotes. And once again, we'll notice one's positive because that's for the one that has here a positive slope, and one is negative, that's for the other one that has a negative slope. And again, that's based on the a and b value because this distance here we know is 3. That's the a value, and this distance here would be 5. So that would give you the slope. If we were to go from this point, we would go down 5 and then across here 3. So that gives us a slope of 5/3. All right, so let's look at our next example. Let's say that we have the equation y squared over 25 minus x squared over 81 is equal to 1. Now for this one, we first again want to determine, is this going to be vertical or horizontal? And we notice we have the y squared term first. So once again, if we have y squared, that tells us it's going to have a vertical axis, which means it's going to open up and down. And besides that, everything else is going to be basically the same as we go through and calculate our values. If I can bring this back up. So once again, we want to start by locating the value of a. So we know that a squared here is going to be equal to 25. So a is equal to 5, which means b squared is equal to 81. So b is equal to 9. And c squared is equal to a squared, which is 25, plus b squared, which is 81. So therefore we would have c is equal to 25 plus 81 is 106. And of course, to get rid of the square, we would take the square root. And if you want to approximate this to have an idea, this would be located at approximately 10.3. And I'm going to leave it as the square root of 106 to keep it as an exact answer for us. So now we can actually locate the center. And again, if we look up here for the h and k, we're not subtracting anything from the y, we're not subtracting anything from the x. So once again, the center is going to be at the origin. And then if we go to calculate the vertices, well, let's look at the graph first. We're going to have our center at the origin. And let me go ahead and mark off some of our axes here. So if I go up to 10 here and over to 10, negative 10, and negative 10 here. So the vertices, remember, that is going to be the distance from the center to the vertex is going to be a. So our a value is equal to 5. And because this is vertical, that means we're going to go up 5. So if we count 1, 2, 3, 4, 5, we go up 5 from the center, and we'll go down 5. 1, 2, 3, 4, 5 from the center. And that will give us our vertices. And from this, we know that our graph is going to go something like this. And now we can actually find those points. So that means our coordinate now, we're only moving up and down, so the x is going to remain 0. So the y value then would be either a positive 5 or a negative 5. So there's the two vertices. And then if we want to locate the foci, we know they're going to be on the inside here. And we know that's the distance from the center to one of the foci is going to be the c value. So that's a square root of 106 or 10.3. So we know it's going to be a little bit more than 10. So we know the one focus will be here and one will be down here. And of course, again, the x value is not changing, so that's going to remain 0. If we think of this at the center, 0, 0, that's not going to change the x value. The only thing that's going to change is the y, because we're going up 10 or we're going to go down 10. So the y value is going to be plus or minus the 10.3, or we could simply say plus or minus the square root of 106. And now the only thing we have left to find are the two asymptotes. And we can do that pretty easy by using the formula, because here we know it's vertical. And once again, here we have the equation. If it's going to be vertical, we have k plus a over b, and we have k minus a over b. And I can bring that down here. We would actually have y equals, I'm going to write it as k positive or negative. Let's see, if we have the vertical is going to be a over b. So that's your rise over your run. And that's multiplied by x minus h. So for the example here, we know our k value, once again, is at the origin. So k is 0. Our a value, we look up here above, our a value was 5. The b value is 9. And then x minus 0. So we could certainly just write this as y equals a positive and negative 5/9 x. And that would give us the two asymptotes. Now, if we want to actually draw in the rectangle to identify that, remember we know that that's going to go up here to 5, and it's going to go out how far? Well, it's going to go out a distance of 9, so we're going to go all the way out to here, all the way down so we would form our rectangle here. And the asymptotes, of course, are going to go through the center and through the corners of our rectangle. And there we have our asymptotes. So you'll notice once again that if you are comfortable with finding the values of a, b, and c for the ellipse, they're going to be very similar here. When we're working with the hyperbolas, it's this that we're looking at the a squared is always the first value that's listed here and here, whereas when we subtract, you're having the b squared is always second. And also keep in mind, the c squared is a squared plus b squared. And then, of course, with the hyperbola, we need to actually calculate the asymptotes as well using the given formulas.